Last section in chapter 4 is about applications and models of right triangles. So we know SOHCAHTOA, which is pretty much all we need to know for this section. Hooray! So we need to solve the whole triangle for all the unknown sides and angles. So I think the first thing to do if you have a right angle and you have another angle is to find the angle B first. So to find angle B, we know there's 180 in a whole triangle. We would subtract off the other two angles. And 55.8 degrees is angle B. From there we can use trig ratios, so SOHCAHTOA, to figure out sides A and C. Let's find side A first, just for fun. Using the given angle, 34.2, and the given side, 19.4, that would make it a tangent because A would be opposite, 34.2 degrees, and adjacent is 19.4. So tangent of 34.2 equals A over 19.4. Multiply both sides by 19.4, and A is 13.18, about. So their angle B. And then, honestly, what you could do after that, if you don't want to do another trig ratio, is just Pythagorean theorem, but that's totally your call. Let's do Pythagorean theorem. 19.4 squared plus 13.18 squared equals C squared. Going through and solving for C, you guys know what the steps are to solve for C. C would be 23.46. Okay, so they're always going to give you 3 knowns, and you'll have to find 3 unknowns. A safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. A fire department ladder is 110 feet. What is the maximum safety rescue height? I like to draw pictures for this section especially. So here's our ladder. Here's our building. With flames. We want to know, let's see, we know this is a right angle. We know that this ladder is 110 feet. And we know that this maximum angle can be 72 degrees. So what we're trying to find, though, is the height of this building that is on fire. So we're going to use sine because we're trying to find the opposite with the height of the building, and we have the hypotenuse with 110. So sine of 72 equals x over 110. Multiply by 110, and x is about 104.6 feet. Do not forget labels on questions like this. Okay, so we have a building 200 feet from the base of the building. The angle of elevation to the bottom of a smokestack, so we have a smokestack on top of this building here, is 35 degrees. And the elevation to the top is 53 degrees. Find the height S of the smokestack. So we have the height A of the building and S of the smokestack. We're just trying to find S. It's going to be easier for us right now to actually find A. So let's find A first, and then we can use A to find S, the height of the smokestack. So we're going to use tangent of our smaller angle 35 will be A over 200. So right now we'll leave it exact as 200 tangent 35 so that we don't have any rounding errors later. Okay, now let's use the 53. It's still going to be tangent. This time we have both a plus s over 200. So 200 tangent 53 equals a plus s. A is 200 tangent 35. I can subtract that from the 200 tangent 53 to give me s. And s in this case is about 125.4 feet. Okay. Alrighty, we got a swimming pool, which is 20 meters long and 12 meters wide. The bottom of the pool is slanted, so the water depth is 1.3 meters at the shallow end and 4 at the deep end. Alright, so here's, whoa, that looks crazy. Let's fix it. Approximately. So this is 1.3 meters all the way across, and then it ends up being 4 meters, this whole thing. And we know that it is 20 meters long. Find the angle of depression. So angle of depression is right here. Remember, it's always off the horizontal down. So we're trying to find that angle theta right there. I need to know, I know that that whole thing is 4 meters, but I need to know what this little piece is here, because I actually don't need that 1.3 up above, since I'm only concerned about the angle below the 1.3. So that is 2.7, which I can do from figuring out 4 minus 1.3. This is going to be a tangent of theta equals 2.7 over 20. And remember, when we're trying to solve for an angle, we always take the inverse trig function of the other side. So I'm going to take the inverse tangent of 2.7 divided by 20, and I will get that my angle theta is 7.69 degrees. Okay, we'll do a little bit with some bearings, so some direction. This is a compass, so both of these should be the same. So let's just start with drawing an angle and letting me describe to you what a bearing is. So if this is my direction, let's say that this is 35 degrees off of south. What you do for bearings is talk about wherever the direction is off of first. That's what you mentioned first. So we would say this is south, and then you would say how big your angle is, which is 35 degrees, in which direction you're going now, which is east. So our bearing is south 35 degrees east. Okay, let's have an angle up here. So the angle that we're coming off of is north, 45 degrees in the direction of east. So it's N45E for our bearing. And we have one more example. A ship leaves port at noon and heads due west at 20 knots or 20 nautical miles per hour. So let's draw a picture here while we're talking about it. That looks terrible, but let's just say that's 20. It's doing it for 2 miles, or 2 hours, I'm sorry. So it's not actually 20 nautical miles, it's actually 40 before they change direction. So this is part A, this is point B. Then they change direction north 54 west. So it's going to be off of north 54 degrees. Find the ship's bearing and distance at 3 p.m. So if they still go the same speed, then this distance is 20 at this point, and they want us to find the ship's bearing and distance. Okay, so I need to find, eventually, this whole value over here, C, let's say. What I'm going to do is draw in a right triangle over here because we're only dealing with right triangles mostly. So if I draw in a right triangle, so this is angle C. If we're trying to find side C, that would make sense to be across from angle C. I know that the hypotenuse of this little right triangle is 20. And if I know that I have north 54 degrees west, then I can also find my angle B, my little angle B. So that little angle B there, so it would be CBD, is 36 degrees. And if I want to find these two sides, so this would be side B, side D. If I want to find side B, it would be 20 times the sine of 36. That's solving for it. It's after setting up for the trig ratios here. And side D would be 20 cosine 36. So what I'm doing there is pretty much just making a giant triangle, if you want to see this here. We're trying to find side C. We now have this side to be 40 plus 20 cosine 36, and this side, this side would be 20 sine of 36. Okay, so now we have this really big right triangle, and I can use Pythagorean theorem to find side C. So instead of, I guess I could write this out. I'm still avoiding the rounding here. You could have rounded if you wanted to, but your answer would be a little less accurate. Doing this, I would get C to be about 57.4 nautical miles. Okay. Alrighty. So I actually still need to find this angle A over here. That's my bearing. So if I find angle A, I could now just do a ratio. Now that I have all three sides, I didn't even need all three to do the ratio, but let's do that anyway. Let's do tangent since I had those two originally. It would be 20 sine 36 divided by 40 plus 20 cosine 36. Take the inverse tangent of that ratio there, and I will get my angle A to be 11.82 degrees. All right, and that is my last section in chapter 4 on applications of right triangles.